Now, as we have seen why we are going to see the ratios with respect to only triangles, now let us go a step ahead and see how the different ratios are named. Okay, so the thing, as I have told you, we are going to see all the ratios with respect to right angle triangle. Okay, so let us draw one right angle triangle. Fair enough. And now when I am going to derive the ratios, what I will be doing? Yes, or first of all, let us see. No, fine. So now once I have taken the right angle triangle, let us mark this angle as theta. Now all the ratios will be derived with respect to this angle theta. So this will be your what you say reference, and from with respect to this reference you will be deriving all other ratios. Now let us suppose I have taken this side as A, this side as B, and this side as C. Okay, now with respect to theta, or let us first see how many different combination of ratios could be derived. There are three sides. Okay, so three sides mean there will be six ratios. So the first ratio is A by C, second ratio is B by C, third ratio is A by B, the next one is C by A, C by B, whereas B by A. Okay, so other than this, are there any other combination of ratio which could be taken? So for A, I have taken A by B as well as A by C. For B, B by A and B by C. And for C, C by A and C by B. So I have considered all the possible combinations, isn't it? Yes. Now, with respect to theta, how is this side? Like at what position is this side? Is this side to the opposite of theta? Yes. Is the side opposite to angle theta? Yes. So now instead of writing it as A, what if I write it as opposite side? Okay. So I will write it as opposite side. Similarly, with respect to theta, how is this side? Isn't this side the adjacent side? Yes. So let us write down it as an adjacent side. And what is C? C is nothing but the hypotenuse, the side opposite to 90-degree angle. Fair enough. Let us replace then. This was my A, this was my B, and this was my C. So instead of writing it as A, B, and C, now I will be writing it with reference to theta. Right? So now A will be my opposite side, whereas C is my hypotenuse. So opposite side upon hypotenuse. B is my adjacent side. So adjacent side upon hypotenuse. Whereas A by B will be opposite upon adjacent. Similarly, C by A, C is my hypotenuse and A is my opposite side. C by B, hypotenuse by adjacent, whereas B by A is adjacent by opposite, isn't it? Now, all these ratios which I have taken, they are with respect to angle theta, isn't it? It means the names which will be given to this ratios will be with respect to theta. So this opposite upon hypotenuse is nothing but sine theta. This adjacent upon hypotenuse is nothing but cosine theta. Further, opposite upon adjacent is said to be tangent theta. Further, this another one. Okay, so let me write down it here. This is wait. So this is your adjacent upon hypotenuse. This is cotangent theta. This is secant theta. And this is cosecant theta. Okay. So these are the names for the ratios depending upon the angle theta, or when you have taken the reference angle as theta, these are the ratios which are said to be sine, cosine, tan, cot, sec and cosec. So instead of writing it or pronouncing it as a whole, we use it as a short form. So sine theta is actually pronounced as just sine theta. For cosine theta, we pronounce it as cos theta. For tangent theta, we pronounce it as tan theta. For cotangent theta, we pronounce it as cot theta, secant, sec theta, and cosecant, cosec theta. So these are the short forms we use for the respective ratios. So what is in sine theta? Sine theta is nothing but opposite upon hypotenuse. Cos theta is nothing but adjacent upon hypotenuse. Tan theta is nothing but opposite upon adjacent. Whereas cot theta is nothing but adjacent upon opposite. Further, sec theta is nothing but hypotenuse upon adjacent, and cosec theta is nothing but hypotenuse upon opposite. Okay, now here you are actually seeing 6 ratios. Yes, so are we supposed to remember all the 6 ratios? No, we are going to remember only 2 ratios, and rest all you can find it out. How? So this is in sine theta, which says opposite upon hypotenuse, isn't it? And this is the cos theta, which says adjacent upon hypotenuse. Now as you can see, tan theta is nothing but opposite upon adjacent. So which means tan theta equal to, if I write it as sine theta by cos theta, let us see, do we get the same value? What is sine theta? Sine theta is opposite upon hypotenuse, whereas what is cos theta? It is adjacent upon hypotenuse. So hypotenuse will get cancelled, so you are getting it as opposite upon adjacent. So as you can see, from these 2 ratios, I can obtain tan theta. Now let us come to cot theta or cotangent theta. So if you compare here, tan theta is opposite upon adjacent, whereas cot theta is adjacent upon opposite. Isn't it is a reciprocal? Yes. So cot is a reciprocal of tan, whereas sec adjacent upon hypotenuse, hypotenuse upon adjacent. So sec is reciprocal of cos. So let us write down here, cot theta is reciprocal of tan theta. Sec theta is reciprocal of cos theta, whereas cosec theta will be reciprocal of sine theta. As you can see, it is opposite upon hypotenuse, and here it is hypotenuse upon opposite. So basically you are going to remember only these 2 ratios, sine and cos. Tan you can find by dividing sine by cos. Cot is reciprocal of tan, sec is reciprocal of cos, and cosec is reciprocal of sine. Okay, so please remember the ratios. They are very important. Yes, sine is opposite upon hypotenuse, whereas cos is adjacent upon hypotenuse. And so whenever you are taking sine, so with respect to one angle you are going to consider, isn't it? Here I have taken my reference angle to be theta. If my reference angle would be here theta, or let us say if I call it as an alpha, so for with respect to alpha, this would have been my opposite side, isn't it? And this would have been my adjacent side. So it depends upon reference to what angle you are taking. So respectively, the opposite side and adjacent side will change, isn't it? For the all 2 angles, you will not get the same opposite side, right? So with respect to the angles, the opposite side and adjacent sides will change. Okay. So now, when I'm saying sine angle A, yes, so when I'm saying sine of angle A, it doesn't mean I'm taking a product of sine and angle A. No, the sine is actually of no value without the angle. Not only sine, all other ratios. These ratios has to be accompanied by some angle, then only they will have value, isn't it? See, what you are doing, you are actually finding the ratio with respect to some angle, isn't it? Sine theta means sine of that theta is nothing but opposite upon hypotenuse. So somewhere you have to have that angle, then only you can find which is the opposite side to that angle or which is the adjacent side to that angle, isn't it? Yes. So what does it mean? This sine A, when I'm writing, it doesn't mean I'm multiplying sine with A. Sine A is together a one word. Yes, and without the angle, this will not have any value. Just sine will does not have any value. Sine A means with respect to A, I am going to find the opposite side and the hypotenuse. Similarly, whenever you are writing it as, suppose I have to take square of this. Fair enough? Yes. It means sine A will be my opposite upon hypotenuse. So it will be opposite upon hypotenuse square. So whatever are the values for opposite and hypotenuse, we can take its value and we can take square of it. Now, for this sine A of bracket square, it could also be written as sine square A. Both are actually the same. For our convenience, we write it as sine square A, which is nothing but equal to sine A bracket square. Yes, but if I write sine A inverse, okay, what does it mean? It means it cannot be written as sine inverse of A. No, these are actually not equal. With respect to square, you can write it as sine square A. But when you are taking inverse, now what is inverse of sine A? Yes, it is cosec A. Yes. So if I write it like this, cosec A is nothing but inverse of sine A. So you have to write it as sine A, and to the power I will write it as -1. You cannot write it as sine minus to the power of -1 and then A, because these two are actually the different values. Okay. So I hope you understood like the difference between these two. Yes. Now the next thing is, will the value of theta be different if there are two different triangles? Yes. Will the value of theta be different if there are two different triangles? For example, let us take one triangle as ABC. So this is my triangle, which is a right angle triangle, and suppose this is my theta. So what will be sine theta? It will be opposite upon hypotenuse. So opposite is BC, upon hypotenuse is AC. Okay. Now I am drawing one more perpendicular inside the triangle, and let us name it as PM. Okay. Now with respect to triangle APM, what is sine theta? It is opposite, which is PM, upon hypotenuse, which is PA. Now the question is, are these two values different? Meaning, is the sine theta value different for two different triangles or for two triangles with two different lengths? Yes, let us see. If I consider triangle PAM and triangle CAB, angle M and angle B are equal, both are 90 degree. Angle A is the common angle. Yes. So by similarity criteria, triangle PAM is similar to triangle CAB, isn't it? If the two triangles are similar, the ratios are also equal. So which means PA upon AC will be equal to PM upon BC will be equal to AM upon AB, isn't it? Yes, two triangles are similar, hence their ratios are proportional. Let us rearrange the ratios and let us see. See, here I want BC upon AC. Okay, so what if I take these two ratios and shift this BC to this side, whereas this AC to this side, this PA to this side, what it will be? So it will be, after shifting BC, let BC will go here and PA will come here. So BC upon AC equal to PM upon PA. Will the value change if you interchange the sides? Yes, no, they will not change. As you can see, BC upon AC is nothing but the value of sine theta with respect to the outer bigger triangle, that is ACB, and PM upon PA is the value of sine theta with respect to the smaller angle PAM. And if you are getting these two values as equal, what does this mean? The sine theta value for triangle ABC is actually equal to sine theta value for triangle PAM. Yes, so what you can say, that the value of the ratios doesn't change with respect to lengths of the sides of triangle, isn't it? Which says values of ratio, they don't change. Yes, they don't change with respect to lengths of sides. So it means if I got to find the value of some angle, for example, if I take value of theta as to be 30 degree, so whether it is present in triangle PAM or triangle CAB, the value of sine 30 will always remain same, irrespective of what triangle you are considering. Okay, yes, so what is sine? Opposite upon hypotenuse. What is cos? Adjacent upon hypotenuse. Tan is opposite upon adjacent, whereas cot is adjacent upon hypotenuse. Sec is hypotenuse upon adjacent, and cosec is hypotenuse upon opposite. Now we know these ratios which we have seen with respect to the triangle, isn't it? Now let us try to visualize this ratio. Yes, let us try to visualize this ratio in an Cartesian plane. Now why we are doing this? So that it will be very easy for you to find the values when you are considering the different angles. Okay, so let us take y-axis and x-axis. Okay, now here I am drawing a circle of unit radius, that is radius equal to 1, taking the origin to be the center. Okay, so I am drawing a circle out here. Fair enough? Okay, now the triangle for which we have considered all the values, that considering this as theta 90. Now I will draw this triangle here in which the hypotenuse will be 1. Why? Because I have taken the circle with unit radius. So let us draw. Suppose this is my point P. This is my angle theta, and this is 90-degree angle. So what will be the value of hypotenuse? It will be 1, isn't it? Because that is the radius for that circle. Now, if let us try to find the values here. Now, what is sine theta? Yes, sine theta is nothing but opposite upon hypotenuse. But what is the value of hypotenuse here? So it is nothing but 1. What does it mean? The opposite side value is nothing but sine theta, wherein I have taken the radius of the circle as 1. So this is an opposite side for theta, so it will be sine theta. So this value, suppose if I name it as POQ, so PQ is nothing but sine theta. Similarly, OQ is an adjacent side, so cos theta will be adjacent upon hypotenuse. Again, hypotenuse is 1, so this length will be cos theta. Okay, now how will you represent tangent theta? Yes, tangent theta is nothing but a tangent which is drawn at point P. So let us draw a tangent at point P. Yes, now this tangent, wherever it is intersecting x-axis, so from this point P to the point where it intersects x-axis, this length is nothing but tan theta. This length is nothing but tan theta. Why? Because it is a tangent. Similarly, the distance from point P where it intersects y-axis is nothing but cot theta. Just try to visualize it properly. It is very, very useful whenever you are finding all the ratios. Okay. Further, so I have got sine, cos, tan, cot. Now what is the sec, or which length is said to be sec? The length from the origin where the tangent intersects x-axis is called as sec theta. Similarly, the length from the origin where it intersects the y-axis is called as cosec theta. Okay, if you understood this figure properly, you will be understanding all the values of the ratios. Okay, so what is sine theta? The opposite side is sine theta. Why? Because since the hypotenuse is 1, similarly the adjacent side is cos theta. If you draw a tangent to the point P, the point line where it intersects x-axis, this length is nothing but the value of tan theta, whereas this length is nothing but the value of cot theta. The distance from the origin to the point where the tangent intersects x-axis is sec theta, whereas the distance of the point from the origin where it intersects y-axis is cosec theta. Okay, so this is the visualization on a Cartesian plane of the different ratios.